Well, hi guys. We're going to have a look in this session at solving quadratic equations using two concepts. That is, firstly we're going to use interpolation, and then in the second part of this, which I think I'll do in a separate video segment, we'll have a look at the discriminant. Mr. Discriminant is a superstar in the land of the quadratics. This first concept we're going to look at is interpolation, however, and we will deal with that now. It's a pretty minor player, so I wouldn't get too stressed about that, but we might as well have a look at it anyway. Okay, solution to quadratic equations using interpolation. This is a trial and error technique which is used to find non-whole number solutions to quadratic equations. It is an iterative procedure, okay, and it produces an approximate result. This is the procedure, guys. First of all, we use a CAS calculator to produce a graph of the quadratic, and then we read off the approximate values of the x-intercepts. That is the solutions or roots of the quadratic equation y equals 0, right? Okay, then when we've done that, we go through this iterative procedure. We test various values of y for the x values close to the estimated roots, alternating between positive and negative values of y, and always choosing x values so as to get closer and closer to the 0 result. Now, that might have sounded very, very confusing. However, I will show you what to do. Okay, it's pretty easy if you just keep your head and be systematic about it. So here's an equation for us. We're solving x squared minus 3x minus 7 equals 0 by interpolation. Well, there's our graph, guys. And if you look at that graph and examine the scale of the x-axis, it looks like we're talking about approximately minus 1.5, that is the x value, where the red quadratic graph crosses the x-axis, in other words, where y equals 0. That's what we're interested in, okay, because y is x squared minus 3x minus 7, and it equals 0. That's what we're solving for. And approximately 4.5 is the other one. Now, we'll take the 4.5-ish solution and see if we can just get a little bit better than that by trial and error as follows. If we try the value of x is 4.5 and we work out y for that particular x value, we do the number crunching and we get minus 0.25. Now, here's the key, guys. You have a look at that graph. Now, look at the red line, the graph, okay? That steep looking graph there over on the right hand side of the y-axis, where you can see that the root is approximately 4.5. Now, to the left of that value, 4.5, where x is less than 4.5, you can see that the graph goes into the negative. The y values go steeply downwards as x moves to the left or less than 4.5, doesn't it? Okay, so that would indicate if you get a negative answer, we're not right on the root, are we? In fact, if you look at the graph, we must be slightly to the left of it because we got a negative answer for y. Do you understand that? So therefore, we'll try something a little bit more on the other side of our supposed solution at around about 4.5 for x. So I'm trying 4.7. Now, we get plus 0.99. So if you also look at the graph again, that red graph, you can see that it becomes very rapidly positive as you move to the right from that x value of 4.5, you see. So that means we've overshot. We've overshot the root, okay, and we've gone too far to the right. So what we might as well do now is split the difference between 4.5 and 4.7. You see, we've got negative values of y for x is 4.5, and we've got positive values of y for x is 4.7. So let's split the difference, and we can say let's try x is 4.6. And this is what you do through this whole procedure. You just keep trying new values getting closer and closer and closer to a 0 result for y until you get something that's so close to 0 it'll have to do. So 4.6, okay? So what do we get when x is 4.6? We get, if we do the number crunching, we get 0.36. Well, that's closer than 0.99, which is what we got when we tried 4.7. So therefore, now our to the left of the root reference point is still x is 4.5, and now we've refined our to the right of the root reference point where x is, say, 4.6. So now we're dealing with 4.5, that's to the left of the root where y is negative, and we've got x is 4.6, which is to the right of the root where y is just positive. So we better split the difference again, guys, you see. We'll try 4.55 now, okay? So you see what we're doing? We're getting closer and closer and closer. Ooh, that's 0.0525, which means we're getting pretty close now. But it's still positive, isn't it? Yeah, so therefore our reference point to the left of the root is still 4.5, and our reference point to the right of the root, where we're getting a positive answer, is still 4.55. So let's split the difference again, 4.52. Okay, see, get the idea? It's iterative, isn't it? It's a repetitive procedure, just honing in, getting closer and closer. So that one gives us a negative answer. So that means we're now to the left of the root. So now let's just regroup. Our to the left of the root reference point is now 4.52, and our to the right of the reference point value of x is 4.55. So we're going to split the difference again and go for 4.53. Okay, we get a negative answer again. Okay, so now we're saying 0.53 is to the left of the root, and 4.55, I mean, 4.53 is to the left and 4.55 is to the right, so we'll go for 4.54 now. We must be getting very close now. Look at that. Y is minus 0.0084. If we're still not happy, we could split the difference again between 4.54 and 4.55. That is our negative and our positive latest reference points, and go for 4.545. And my goodness, we get 0.022, so it's got to come back, okay, a little bit to the left of 4.545, and continuing this process, it can be found that if you want to drive yourself crazy and keep doing it a few more times, you'll get 4.541, okay, and the same whole process that we've just been through can be used to find the approximate value of the negative root, which we identified earlier was around about minus 1.5. Alright, so that is the procedure that we go through by interpolation, guys. Okay, it's pretty boring, isn't it? But it's nevertheless effective if that's really the option that you want to pursue. Alright, well, I'll see you in the next video when I'll have a look at Mr. Discriminant, okay?